I'm here at Structure Connect with Don Butler, who's the Executive Director of Ford's Connected Vehicle and Services Program. Don actually spoke earlier today at Structure Connect about a whole bunch of topics. I mean, we covered, a lot of things right now. Autonomous driving, vehicle-to-vehicle communications, obviously the Sync App-Link development program, and, technologies that basically touched upon it. We only had 15 minutes though, and there's a couple things that we didn't get to, and so I wanted to kind of see if we could follow up with you about some of the the kind of peculiarities of of the cars that Ford develops today. I mean, basically, and you're kind of grounded in this job as you're kind of bridging Silicon Valley and Detroit, and and these are very, very different industries that are used to working at very, very different development paces and that kind of thing. I mean, in Silicon Valley, apps get out the door just like that. I mean, new phones are updated every single year, and while there are new models of vehicles coming out every year, I mean, my understanding is that they have very, very long development cycles. So I guess my question would be how do you work at that Silicon Valley pace? How do you build a car that doesn't become obsolete the moment it rolls off the lot, so to speak? So
Kevin, it's a huge challenge, and as you mentioned, the development life cycles and even the life of products is very different between consumer electronics and the vehicle side. It takes us anywhere from 3 to 4 years to develop a particular architecture, vehicle, or platform, and then once that vehicle's introduced to the public and someone purchases it, it lasts up to 10 years, even longer, right? And so that is a big challenge: is how do you make sure that that vehicle can continue to be better over time? And the really good thing, though, is as things become much more software enabled, the capability that you can do through software really kind of supersedes some of the hardware limitations. I mean, just as an example, a few years ago there were only a handful of microcontrollers on a vehicle, less than a handful, literally. And now there are some 70 microcontrollers and over 200 million lines of code within our vehicles. So the vehicle is becoming much more software-based. So that's one of the ways that we address obsolescence. The other way is by leveraging things like AppLink, for instance. And so not relying on what the vehicle brings, but relying on that smart device, for instance, and the capability of that smart device and the applications that are resident on that smart device, and enabling those applications even as we go forward into the future. So setting up a structured, kind of open standards, API-based way of interacting with those applications, so as they continue to evolve and get better, you still have that delightful experience inside the vehicle. I think the other thing that I'd say as well is what we're seeing today, and we're seeing it actually within computers and within the tech industry overall. It's less about more and more computing power, and it's more about the experiences that you deliver, right? And so with the right kind of established level of computing power, with the right level of memory, again, as you go back to what software is able to do, you can deliver actually better and better experiences over time by leveraging different data sources, by leveraging different capabilities from the outside world, for instance, and continuing to deliver that great experience, again, because it's software enabled, because the computational power, it's not necessarily driven by MIPS, it's driven by what you do with them. And the other thing that we do finally is, we participate in events like this at Gigaom, where we learn and sort of surround ourselves with that culture. And so we've got folks here on the AppLink team, for instance, that are interacting with potential developers and existing developers. And so we want to have that environment kind of permeate who we are as a company as well, because that also comes into bear when we think about experiences and we think about becoming much more of a software-driven company as opposed to a hardware-driven company.
And I definitely see where you're going with that. I mean, the idea is that, if you have a bring your own device, bring your own connectivity kind of approach, you're kind of upgrading the infotainment system every 2 years when you upgrade your smartphone, right? But there is hardware embedded in the vehicle. There's display technologies, there's your voice command and control system. I mean, there's just the processors that process the images that are on the screen, and in the fast-paced world of silicon, the chip that comes out this year is, in the smartphone or tablet or even PC world, it's practically a dinosaur like a year or two later. Do you find yourself, are you looking at options in which you would be able to actually upgrade the hardware within the vehicle, whether it's like the microprocessor pack or kind of I remember when I bought my first Nintendo 64 when I was a kid, you could buy a little memory
the cartridge,
pack.
yeah, I remember,
stick in and like all of a sudden it had 128K of memory, and then like, but
we're considering modularity and upgradability for a couple of different reasons. Number one, as you mentioned, as we go forward, my customers be in a position of wanting to upgrade that center stack, that screen, for instance. We're also looking at modularity in terms of ongoing development, because the one thing that we see is that when you have a platform-based and a standards approach, you actually are able to iterate much more quickly. And so if we've got sort of standardized modules around, the network communication device and or the microprocessor, then we might be able to increase our pace of development by swapping out those modules as opposed to designing the whole hardware platform from scratch. And so both from the standpoint of consumer upgradability as well as from the standpoint of facilitating faster development pace, we're absolutely looking at that in terms of a platform-based approach.
I mean, how do you think that would look? Would I be able to go to AutoZone or Best Buy and buy like a Ford, the new Ford Sync system and swap it out, or would this be something that would go to my dealer, or this would
honestly,
be more,
because our dealers know the vehicles best, as we go forward in the future, that would be the way that we would sort of bring that to life. And even today, right, with what we've been able to do with Sync and My Ford Touch and My Lincoln Touch, the ability to upgrade and make that software, make that experience better over time. We're doing it today through USB devices. As we go forward in the future, it'll be through things like Wi-Fi and embedded modem capability on the vehicle. And so we want to make it as easy as possible to make sure that our vehicles are able to become better over time.
Well, one last thing I wonder if you could touch on. It's a program that I think this is one of those fascinating programs at Ford. It's called OpenXC.
Yeah.
I was wondering if you could tell us a little bit about it. I mean, essentially, it's an open source software and open source hardware program that where you could. A good example is you basically working with a company called Automac. They can plug in a module into the car that can bring Siri capabilities to older vehicles long before Apple Play is even available in the first Ford, right? So.
Yeah, we know that in this space, whether we're talking connectivity or mobility, the way that we are going to create the future is not by ourselves. It's not independently. I also touched on the fact that we want to kind of inculcate this atmosphere of Silicon Valley and innovative thinking, and so the best way to do that is to begin to work with and experiment with partners, and Automatic's a great example of that. We leverage some IP that we've got around how to activate Siri, and with their plug-in device, we partnered with them and provided that capability, and it's a chance for us to learn. It's a chance for us to learn how a small company works and how they behave and how they act. It's a chance for us to understand from a software standpoint, being able to deliver that kind of capability to vehicles that are old, right, and potentially would have been viewed as obsolete in the past. The other thing that it does for us as well is it enables us to understand what are the sources of value that might be created as we go forward in the future. And when you talk about the OpenXC platform, it's basically a way for us to expose the types of data that's available on the vehicle and partner with folks to think about applications and experiences that we couldn't even have dreamed of a few years ago. And so it's this notion of open source, it's this notion of exploring together and creating better experiences for our customers over time.
So a quick follow-up, do you view OpenXC then more as kind of an R&D effort that kind of educates you, that as opposed to something that commercial devices will be built on?
Yeah, it's much more, I would say it's much more in the R&D realm right now in terms of learning and experimentation. And as we see ideas that may bear fruit, then we'd look at, okay, how do we productionize that? How do we bulletproof it? How do we handle things like security? All that would need to come into play as we would move forward with an actual production application.
It just would have been much easier to say you could pimp out your connected car with OpenXC. But
when you're talking about a vehicle, right, in particularly in terms of security and safety, you got to be very, very, very careful. So OpenXC is really more around experimentation at this phase, but we're learning, and that learning will be incorporated as we go forward in the future.
Very cool.
All right.
Well, anyway, thank you very much for joining us.
Kevin, always good to speak with you.